Hello guys, welcome to Sunya IAS. So today we are going to discuss the questions of a very important chapter, that is number system. And why it is important? Because every year around 5 or 6 or 7 questions are being asked only from this particular topic, so you can understand the gravity which this particular topic holds, right? So one important thing here is that the other questions, the other chapters which we saw, were having a particular approach in which you had to write an equation and solve that equation. If you remember, we started from average, then percentage, LCM HCF, ratio proportion, profit and loss, mixture allegation, time and work, and then we reached the climax at speed, distance and time. Now this particular topic is quite off the wall and it is having a quite different approach than the previous chapters we saw. So for this, I have a very special word. This chapter is nothing but guerrilla warfare, where there is no particular technique. You have to just, give different approaches. You have to just play with numbers. And that is the art of this number system chapter, is that there's no particular approach, but you have to just play. And that is the approach we are going to follow. And based on this art of playing with numbers, we have separated and segregated various questions together so that similar questions are placed and you can understand the concept behind them and you can solve them easily. Also, one more thing is there, that since there are a lot of questions being asked from this topic, one video cannot be enough. That is why we are not having just one, just not two, but actually 3 videos to cover this entire topic. Okay. So without any further delay, let us begin our discussion for this particular topic. As you can see here, this is a sneak peek of our online course, and we also offer offline batches so that you have the rigorous practice in a group setting so that you are able to feel the heat of the exam, simulate the experience of the actual CSAT examination, so to say. And so we'll begin the discussion about number system. So number system, let us talk about numbers. What are numbers? So we know that 1, 2, 3, 4, 5 and so on. All these are numbers, and there is a particular term which is called natural numbers to define them. These numbers are called natural numbers because they are found in nature, and these are the numbers that you can count. Okay. If I include also 0 in the whole sequence, it becomes 0, 1, 2, 3 and so on till infinity. This particular series which includes 0, this series becomes whole number because it is including all the numbers that you can count and also 0, right, which is the base of all the numbers, which is the root of all the numbers. Then if we include the numbers on the positive side, there are also numbers on the negative side. These numbers are called integers. So they start from minus of infinity, they go in 0 in the between. Here you have negative numbers minus 1, minus 2, minus 3. And here you will have positive numbers 1, 2 and 3. And they will again go till infinity. These are called integers, right? After the integers, we have numbers called decimals and fractions. For example, you can have the decimal 0.1, or you can have the value 0.66, or you can have the value 0.66666, which goes on. Similarly, these decimals can also be written as fractions. So we have fractions. So this 0.1 can be written as 1 by 10. This 0.66 can be written as 66 by 100, further cancelled out to be as 33 by 50. And here you can see this decimal is actually nothing but the fraction 2 by 3, right? So here also you can see various type of fractions. These are the decimals in which the amount is stopping after a certain value, so it's terminating decimal. So both of these decimals are terminating decimals. And here you can see in this fraction 2 by 3, when you convert it into a decimal, it keeps on going 0.66666 till infinity. So such a decimal is called recurring decimal, because a certain digit here 6 is repeating or recurring after so many times, infinite times. Okay, so this is the idea of decimals or fractions, and particularly terminating decimals and recurring decimals. So all these numbers can be called as rational numbers. So the name given to these numbers is rational numbers. So if these numbers are rational numbers, it is imperative that there should be some irrational numbers also, right? So what will be the irrational numbers? The irrational numbers are such as pi, such as root 2, such as root 3, and so on. So what is happening with these, irrational numbers is that when they are converted into decimal, they neither terminate like these two, neither they have any repetition pattern like the recurring ones. So they, when these values are found, these values are neither terminating nor recurring. So these numbers keep on going. If you see the value of pi, it keeps on going and different numbers are there. There is no repetition at all. Okay. So these all are irrational numbers, and therefore if we include this irrational number also and the rational number also, overall whatever the number we have, those will be real numbers. Okay. I think so far as CSAT is concerned, our discussion be limited to this part only. You must know the basics about this, that the introduction part, nothing more detail is required. And then further we can discuss a few more things such as even numbers, odd numbers, then we have prime number and composite number. Okay. So if we talk about even numbers, they are nothing but the multiples of 2. We have 2, 4, 6, 8, 10. All of these numbers will be even numbers. And so the remaining numbers are going to be odd numbers. We have 1, 3, 5, 7, 9, 11, and so on will be the odd numbers. If we talk about prime numbers are those which have only two factors. One is 1 and the other one is the number itself. So such numbers are 2, 3, 5, 7. 9 will not be a prime number because it has factor of 3 also. Then we have 11, 13, 17, 19, and so on. Now here one thing is there. 1 is not a prime number because 1 is having only one factor, which is 1. Okay. The criteria for prime number is it should have two factors, the number itself as well as 1. Now if you can see, 2 is the only even prime number. Apart from it, there is no other even prime number because all of them will definitely have a factor of 2, right? All of them are remaining are odd. Now what about composite numbers? Composite numbers are those numbers which are not prime and which are found by multiplication of different values, different prime numbers. For example, you can have the number 16. It is formed by various factors. It is having a factor of 8 also. It is having a factor of 2 also, 4 also. Okay, so it is a composite number. Similarly, you can have 15. It is having a factor of 3, factor of 5 also. Similarly, you can have a lot of numbers which are composite. Basically, the numbers which are not prime are composite in nature. Okay, so these are all the basics which will be required to solve the questions. So now we'll begin the discussion of the questions now. So we have this question and we have to consider the two statements. The question says, is x an integer? We have to tell whether x is an integer, yes or no. Okay, let us read the first statement. The first statement says x by 3 is not an integer. So it says that x by 3 is not an integer. So what we can do is that there is no single approach to solve it. We can just try with different value of x and check whether x is an integer or not. So suppose if we put the value of x as 5, let's say, we know that x by 3, which is nothing but 5 by 3, is not an integer. But as you can see, x equal to 5 is obviously an integer, right? Similarly, we can take another case where we can take the value of x as nothing but 6. So x by 3, that is 6 by 3 is coming out to be 2 and 2 is an integer, right? So here you can see x is also an integer 6, which means it doesn't matter whether x by 3 is an integer or not. X can be integer. It doesn't matter whether x by 3 is an integer or not. So the first statement cannot help us to answer the question. Okay. Now we look at the second statement. The second statement says if 3x is an integer, then x is also an integer. So let us take the second case now. So I'll use the navy blue color here. 3x is an integer. So if we assume that 3x is equal to 5, it is an integer, then x comes out to be 5 by 3, which is not an integer, right? But if we take the value of 3x as 9, we get the value of x as simply 3, which is an integer. So basically, it simply means that whether 3, 6 is an integer or not, it doesn't matter that x will be an integer. Okay, so this statement also will not be able to answer the following question. Okay, so here we can say that both statement 1 and statement 2 are not sufficient to answer the following question. So as you can see, the approach here is quite different, and in the next question also you can see the similar thing. So here is another question which says consider two statements S1 and S2, and there is a question following it. The statement 1 says P and Q both are prime numbers. Okay, so P and Q are both prime. The second statement says P plus Q is an odd integer. So P plus Q is odd, right? Now the question says, is P into Q an odd integer? So this is statement 1, this is statement 2. What about the question? The question says, is P into Q odd? P into Q is odd is the question. So before starting the question, we must know one basic thing about it, is that when we add an odd number and an odd number, here it is O and O, which is signifying odd, the sum is always an even number, right? Similarly, if you add an even number and even number, the sum is always an even number. Let me show you an example so that you trust my statement. Let us take odd number as 3, another odd number as 3. The sum is 6, which is even. Similarly, if we take the even number as 2 and the another even number as 4, the sum is 6, which is an even number. But if you want the sum to be odd, for that there is only one criteria, that is you have an odd number and an even number. When you add them, you will get an odd number. Okay. So what about it now? So if you take odd number as 3 and you take even number as 2, the sum is coming out to be 5, which is definitely an odd number. So that is the basic criteria. Now if it says if P and Q, the sum is coming out to be odd, it basically means that P and Q, out of them one is even and another is odd. That is the similar idea which is shown in this particular concept which I just explained you. So either P can be even and Q is odd, and similarly P can be odd and Q can be even, right? Now the question further says that is P into Q an odd number? So the basic idea is, if you multiply an odd number with even number, the product is going to be definitely an even number. Why? Because there is already a factor of 2 in the even number. So the final product will also contain a factor of 2. Let me verify this statement by an example. Let us take the odd number to be 5 and even number to be 2. When they get multiplied, they form 10. So 10 is an even number. So when you multiply P and Q, if one of them is even, the overall product will be even. So is PQ an odd integer? No, PQ will be an even integer because one of them is even. And how could we figure this out? We could figure this out using this particular statement. What about the first statement? Statement 1 is of not much use in our case. This statement 1 can help you only to find out that one of these values can be 2. How? Because it says P and Q are prime, and it says out of them one is even. So there is only one even prime number, that is 2. So you can just figure out that okay, one of them is going to be 2 in value. Apart from that, it is not going to help you in decoding any other information. So statement 1 is of not much use, but statement 2 is very important to solve the question. So we can say option number B, statement 2 alone is sufficient to answer the following question. Okay, so here also you can see the approach is quite different, and that is what you have to catch. Next we have the question number 3. Consider the following statements in respect of two natural numbers P and Q such that it says P is a prime number and Q is a composite number. You know about composite and prime numbers, right? It further says, can P and Q be an odd number? The first statement is saying, can P and Q, P into Q, sorry, P multiplied by Q, can it be an odd number? Why not? If you take the value of P to be, let's say 3, and you take the value of Q to be, let's say 15, both of them are odd numbers. When you multiply 3 into 15, you get the product as 45. This is also odd. So it is correct. P into Q can be an odd number, right? Moving on, we have P by Q. Can it be a prime number? So if we talk about P by Q, we will have 3 by 15. They will cancel out. You will get 1 by 5. You will get a fraction. Okay. So if one of them is prime, other one is composite, they will not cancel out each other completely. That will mean you will always get some fraction, and therefore fraction cannot be a prime number. So this statement number 2 is incorrect. Finally, about statement 3, we can say P plus Q can be a prime number. So let us take the third statement, P plus Q, can it be a prime number? Yes, it can. If we take the value of P as 2 and the value of Q as 15, so here P is prime and Q is composite. If we take the sum, we have 2 plus 15, the value comes out to be 17 and it is a prime number. So statement number C is correct. P plus Q can be a prime number. Okay, so statement number 1 and statement number 3 are correct. So we have option C as the correct answer in this particular question. So these 3 questions were of somewhat similar approach, where you could have checked whether the statement is correct or not by putting different values according to your choice which satisfy the criteria. Okay. Now let us look at these questions. The question number 4. It says the sum of 5 consecutive integers can be 100. Okay, so what are consecutive integers? These are those integers which are neighboring to each other, right? Suppose you have an integer x, the next one will be, the neighboring one will be x plus 1, x plus 2, x plus 3, x plus 4. These will be the 5 consecutive integers, right? We can also write these integers in a different way. What will be the different way? We can say that the middle one is x, so the front one will be x plus 1 and x plus 2, and the back ones will be x minus 1 and x minus 2. This is the another way of writing 5 consecutive integers like this. So I'm erasing the red one and I'm leaving the blue one, because that is a better strategy of writing. Why? You will realize that very soon. Because when we take the sum of these 5 consecutive integers, we have x minus 2 plus x minus 1 plus x plus 1 plus x plus 2, and the sum is coming around to be 100. So minus 2 and plus 2 are cancelled, minus 1 and plus 1 are cancelled, and we get the overall sum here as 5x, and this value is equal to 100. So you can say the middle value is 20. So if this is 20, they are going to be 21 and 22, and they are going to be 19 and 18, right? So this is the basic idea. So yes, sum of 5 consecutive integers can be equal to 100, and these are those 5 integers whose sum add up to 100. Now let us look at the second statement. The product of 3 consecutive natural numbers can be equal to their sum. So there are, the question is saying 3 natural numbers. First, focus on the word natural numbers whose sum is equal to their product. So suppose the 3 numbers are P, Q and R. It says that P plus Q plus R, the sum is equal to their product, which is P into Q into R. Now let me tell you one thing. There are only 3 such numbers which satisfy this criteria. Okay, so when we are talking about natural numbers, we simply have 1, 2, 3, because 1 plus 2 plus 3 is also equal to 1 into 2 into 3. When you add them up, you get 6. When you multiply them, you get 6. So only these values satisfy the criteria. Okay, this statement is also correct, but only for this one case only. So here both the statements are correct. We have option number C as the correct option in this particular case, right? Now we'll look at a similar question, that is question number 5, which says that sum of 3 consecutive integers is equal to their product. So how many such possibilities are there? So from the previous question, you will just jump up and say, yeah, only one, option number A. That's quite simple. But guys, that's not so simple, because you might be ignoring one very important word, which is this, integers. Okay, if you look at the last question, it says natural numbers. So only one set is actually satisfying the criteria. When we talk about integers, not natural numbers, but integers, we can also include negative numbers as well as we can include 0 also. So now in this discussion, we have negative numbers plus 0. So one of the possibilities was 1, 2, 3, because their product was coming out to be equal to their sum. We can have one similar way of writing the 3 numbers that will all be negative. So we have -1, -2 and -3. Here the product will be -1 into -2 into -3, and their sum will be -1 plus -2 plus -3. Okay. So when you calculate the values, here the 2 negatives will cancel out. You get 1 into 2 into 3, which is 6, but one minus sign will be there, that is -6. Here we have -1, -2, -3, and overall these 3 values will add up to form -6 equal to -6. This is another pair which is satisfying the criteria. Apart from it, there is one more pair which you can think about, because now we are including 0 also in the discussion. We can have a third pair which is satisfying the criteria, that is -1, 0 and +1. So when we multiply these values, we multiply -1 into 0 into +1. And when we add these values, -1 plus 0 plus 1, you can simply see here when we multiply any number by 0, we get 0. And here this -1 and +1 will get cancelled. Again, you will get a 0. So this also satisfies the criteria that sum is equal to the product, right? So here we can say there are not only just one, but overall there are 3 possibilities which I have written. So this is 1, this is 2, and this is 3. Okay. So we'll move on now to the next question, number 6. For what value of n, the sum of digits in the number, this is the number, is 2. So if you look at the number which is 10 to the power n plus 1, what we have to do, that we have to just apply different values. So we can check for n equal to 1, we can check for different values of n. So if we check for n is equal to 0, we get the number as 10 to the power of 0 plus 1, which is 10 to the power 0 is nothing but 1. Any number to the power of 0 becomes 1. Okay, that is the basic idea being followed here. So the number becomes 1 plus 1. The sum of digits is obviously 2. If we take some other value, let us take the value of n is equal to 1. If we take the value of n is equal to 1, we get 10 to the power 1 plus 1. It becomes 10 plus 1, that is 11. Here also sum of the digits is 1 plus 1, that is 2. Suppose if we take the value of n is equal to 2, we get 10 to the power of 2 plus 1, which is nothing but 100 plus 1, which is 101. Here also the sum of digits is 2. So if you take any power of 10 in any number, 3, 4, 5, 6, 7, 8, whatever be it, the number will be in the form of 1, 0, 0 and so on, a lot of zeros, and it will end with 1. So no matter what the power is, the sum of the digits will always be equal to 2. That is the basic idea here. Okay, so let us check the options now. So option number 1 says for n equal to 0 only. It is wrong because it is ignoring all these further values, right? Then the option number C says for any positive integer n only. Only positive integers? No, it is also including 0. So positives are 1, 2, 3, 4 and so on till infinity, but it is also including 0. So this statement that positive integers only is also incorrect. What about the statement number B for any whole number n? So yes, this is correct because whole number includes 0 also and all the positive integers also. So we have option number B as the correct option in this case. What about D? It says any real number. So you must know that in real number, we also have the inclusion of irrational numbers such as pi. So if we put the value of n is equal to pi, you will get 10 to the power of pi plus 1. I hope that you are sensible enough to understand that this value is going to be quite horrible. Okay, and obviously we should not be wanting to know what is the sum of the digits in this case. It will be really horrible. So obviously this is not the case. Okay, so look at question number 7 now. In question number 7 and the remaining questions after it will have a certain pattern of reversal of digits. Okay, so let me tell you the basics about reversal of digits. So let us suppose we have a 2-digit number x, y. Here x and y are 2 digits of the number. Suppose we have a number 28. It basically means the tens digit is 2 and the units digit is 8. Now what is the value, mathematical value of this particular digit? The mathematical value of this number is going to be 2. Since it is in the tens place, we multiply it with 10. And since 8 is in the unit place, we just take 8. This is nothing but the mathematical value of that particular number. Suppose we have 792 as a number. Here we have 2 as the unit digit, 9 as the tens digit, and we have 7 at the 100th digit. So the value of this particular number will come out to be 7 into 100 plus 9 into 10 plus 2. That is a similar idea we are going to apply here. And so we will have this value as 10 times x plus y, right? And when we reverse the number, it becomes how much? It becomes y comes first and then comes x. So in this case, the value of this particular number will be 10y plus x. Okay, so this is the basic concept we are going to apply in our discussion of the further questions now. So the question says that the difference between a 2-digit number and the number obtained by interchanging the positions of the digit is 54. So suppose we have a number x, y and we interchanged the digits. So we had y, x. When we subtracted them, we got the number 54, right? So what is the mathematical value of x, y? It is nothing but 10x plus y, as I told you earlier. What is the mathematical value of yx? It is nothing but 10y plus x, and the value is coming out to be 54. When we bring all the terms of x on one side and all the terms of y on one side, we get 10x minus x plus y minus 10y is equal to 54. Here we get 9x minus 9y is equal to 54. When we take 9 common, we get x minus y is equal to 54. And we can cancel them out. We get x minus y is equal to 6. Okay. So here you can say the difference of the digits is coming out to be 6. So now let us read the options. First statement says the sum of 2 digits can be determined only if the product of the 2 digits is known. It is saying that if you want to find the sum, you want to find the value of x plus y, in order to find that, you must only know the product. So this statement is correct. See, seriously, no, it's not correct, because the sum of two digits, if you have to find, we will have to find the value of x as well as the value of y, right? And in order to find the two values, we need two equations. One equation we are having, x minus y is equal to 6. We need one more equation. Now it says that we can know if the product is known. So what is product? It is nothing but x into y. And if we know the product, then these two equations can help us to find the sum. That is correct. But there is only one word which is making the whole of the statement as incorrect, which is only. So the sum of the digits can be determined if we know the product also, but only the product is not the criteria. We can have one more relation between x and y, one more equation between x and y, which can help us to find the values and then the sum. So instead of x into y, we could have another equation. We could have written x is equal to 3y, let's say, for example. If we have one another relation, we can find the values of x and y and add them up. Okay, so this single word only has created this statement to be incorrect. Now we look at the statement number 2. It says that the difference between two digits of the number can be determined. So can we find the difference between the two digits? Of course we can. We have x minus y equal to 6. So difference of the digits is 6. So this statement number 2 is going to be correct, and we have 2 only as the correct option in this case. Okay, so guys, this was one question on the idea of reversal of digits. Let us look a few more questions now. So we have this question. It says, let p be a two-digit number and q be the number consisting of the same digits written in reverse order. Okay, so we have a number which is p. Let's assume p is nothing but x, y, and q is the reverse. So we have y into x. And it says when we multiply p and q, we get 2430. Now you should pay attention to one thing. Out of all the digits, we must focus on this 0. Here the last digit of the product is coming out to be 0. So when does two number give a 0 when they are multiplied? There are only two chances when two numbers are multiplied, they give a 0. First chance is that one of the number is having a factor of 10 directly, or both of the numbers contain 2 as well as 5. These are the only two ways in which you can get a 0 as the last digit. Let me give an example. Suppose you have a number 30, another number as 13. When you multiply, you get 390. There is a 0 at the end because there is the factor of 10. Let us take one more example. We have 25 and we have 4. When we multiply, we get 100. So why there is 0 at the end? Because here we have a factor of 5. Here we have a factor of 2. When they multiply, they give 0 at the end. That is the basic idea we have to follow here. So if on multiplying the two numbers p and q, we are getting 0 as the last digit, that simply means that what is the possibility? The possibility is that either there is a factor of 10. So if that is the case, let us assume this y is equal to 0. So we have first number as x comma 0 and the other number will become 0 comma x. But if you do this, what will happen? So these are two-digit numbers. So q will also be a two-digit number. But if you take 0 as the first digit, it will only become a one-digit number. So suppose somewhere is written 09. What does it mean? It simply means 9. So it is not a two-digit number, it becomes a one-digit number. So 0 wala case, 10 wala case we cannot take. Okay. What will be the another possibility? The another possibility can be that one of the numbers is 5, right? So if we take this x as 5, we get the two numbers as 5y and the other number will be y5. So when these numbers will be multiplied, you will get an 0 in the end only if y is an even number, so that it contains a factor of 2 also, right? So this is the way in which we can get the product as 2430. So now what we have the case as simply this, we have the value of x as 5, so the numbers will be 5y and y5, and we can try for even values of y, that is, we can check for the value of y is equal to 2, y is equal to 4, y is equal to 6, y is equal to 8. These are the only 4 values for which we'll check. We'll not check for y equal to 0, because as you have seen, I told you it will become a 1-digit number then. These are the possible values of y. And if we take y is equal to 2, we get 52 into 25. Here we get 54 into 45, right? Here we get 56 into 65, and here we get 58 into 85. So out of multiplying all the numbers, there is only one possibility, which is this, that these numbers are giving the product of 2430. Apart from this, the other numbers will not give a product of 2430. How did I knew that? Because I just had a rough multiplication. Instead of doing 52 into 25, I just tried with 50 into 20. I got the value of 1000. So this value will be somewhere around 1000, somewhat more than that. This value 50 into 60 will be 3000-ish. This value 50 into 80 will be something in the 4000s. If you take this value 50 into 40, that will be something around 2000, and that is the perfect value we need. So these two numbers multiply to give the value of 2430. That is, P is nothing but, let's say 54, and Q is nothing but 45. When we subtract P and Q, we get simply the value of 9. So it is what is being asked. What is the difference between P and Q? And that difference is nothing but 9. Okay. So this is the correct answer to this particular question of reversal of digits. Okay. Moving on now. We have this question. It says the ratio of a 2-digit natural number to a number formed by reversing its digit is 4:7. It's quite a simple question. So let us assume first number is x, y. The value will be 10x plus y. When you reverse the digit, it becomes y, x. The value becomes 10y plus x. Now it says the value of their ratio is 4:7. So the original number will be in the top because it is given first. We have 10x plus y divided by the number found by reversing. It is this, which is 10y plus x, and the ratio is coming out to be 4/7. 4:7 can also be written like this, 4:7. Okay. We have to just solve these two equations by cross multiplication. So just cross multiply them. We have 7 times 10x plus y is equal to 4 times 10y plus x. Here we have 70x plus 7y is equal to 40y plus 4x, right? When you bring all the x's on one side and all the y's on one side, it becomes 70x minus 4x is equal to 40y minus 7y. It becomes 66x is equal to 33y. Simply you can say that y is equal to 2 times x. This is the relation which we get between the digits if they are having the ratio 4:7. Okay. So now we can check for different such pairs. The question is saying further that how many such pairs are possible. So let me create some space now. So using all the information provided in terms of ratio, we found the relation between y and x. Now we can actually try to find all the such pairs which are satisfying the criteria. So if we take the value of x is equal to 1, y will be equal to 2, first number will be 21, its reversal will be 12. When you take the ratio 12:21, it becomes 4:7 by a common factor of 3. Okay. If you take x is equal to 2, y becomes 4, you get 42 and 24 as the two numbers. Here also if you take the factor of 6, it becomes 4:7. Then we take x is equal to 3 and y becomes 6. we get 63 and 36 as the two numbers. And if you take the factor of 9, they becomes 4 by 7. Similarly, take the value of x is equal to 4. Y will be nothing but 8. The numbers will be 84 and 48. So here also the ratio is same if you take a factor of 12. But if you try to put the value of x is equal to 5, y will become 10 and y cannot have the value of 10 because y is a digit. Okay, and since y is a digit, y can only lie between 0 to 9. So this value is not possible and therefore we will have only 4 such pairs, 1, 2, 3, 4. So the correct number here is 4. That is option number B is going to be the correct option in this particular case. Okay, so we'll move on to the 10th question now. And this question is actually a hit and trial based question. So it is having a quite different approach now. So here in this question, we'll have when a certain number is multiplied by 7, the product entirely comprises only of ones. That is, whatever you multiply, that answer will be 1, 1, 1, 1, 1 and so on. Okay. So what is the smallest such number? So you have to say out of all these 4 numbers given in the option below, when multiplied by 7, give answer only in terms of this 1, 1, 1, 1, 1. How do we find that out? By just simple multiplication with all the options. Okay, but that's the trick part of it. You do not have to actually multiply the complete numbers. All of them you do not have to multiply the whole, but only partially, just to check that satisfying the criteria or not. Okay, so if we multiply this first number by 7, we have 1, 5, 7, 1, 3 multiplied by 7. 7 3s are 21. We have 1 there. Then 2 goes in the carry forward. 7 into 1 becomes 7. Then 2, it becomes 9. So it is having digit other than 1. It is not satisfying the criteria. What about the other number? So the other number is 1, 5, 7, 2, 3. Let us take the case of 2 now. So 7 into, just let me erase it. So here you can see 7 into 3 will be 21. 1 is here and 2 goes in the carry forward. We have 7 into 2 will be 14. 14 plus 2 will become 6 and 1 will go on the carryover. So again not satisfying the criteria. Let us now take the case of 1, 5, 7, 8, 3. Okay, so if we take the value of 1, 5, 7, 8, 3, we have 7 3s are 21, 2 in carryover, 7 into 8 will be 56 and here will be 58. 8 will be the last digit here. That will also not satisfy the criteria. So just one minor correction here, guys. This value is 1, 5. I think it is correct. Let me just solve it. For the last option now, let us check the last option. The last option says the value is 1, 5, 8, 7, 3. Okay. So here the last digit is this. When we multiply this by 7, we get 7 3s are 21. 2 goes in the carryover. We have 7 into 7, which is 49. Plus 2, it becomes 51. We have 1 here and 5 in the carryover. When we multiply 7 with 8, we get 56. 56 plus 5 will be 61. 1 is there, 6 in the carryover. Then 7 into 5 is 35. 35 plus 6 become 41. We have 1 here, 4 in the carryover. Then 7 into 1 will be 7 plus 4 will be 11. So these are all the digits which are there in the number and all of them are 1. So the correct option in this case is going to be option number D, which is 1, 5, 8, 7, 3. Okay, so there is no correction. Sorry for that. All the numbers are different. So the only difference is this is 7, 8, this is 8, 7. So you do not need to actually multiply all the digits. Just, multiply them partially. That is the idea in this question. Okay, so now we have this question. How many numbers are there between 100 and 300 which begin or end with 2? Such are the numbers between 100 and 300 which either start with a 2 or end with a 2. So let us break this question in 2 parts. See, this question is also a hit and trial based question. You do not have to actually, follow any particular approach to solve this. There is no particular approach. But here the idea is just go random. So what we can do from 100 to 199 we can take some digits, and then from 200 to 299 we can take some digits. When we talk about 100 to 199, what are all the numbers which are having either 2 in the beginning or 2 at the end? So obviously from 100 to 199, 1 is in the beginning. So we cannot have the case of beginning, but we can have the case of numbers ending with 2. So what are those numbers? We have 102, 112, 122, 132, 142, 52, 62, 72. Then we have 182, 192. So we have all these numbers. They are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 such numbers from 100 to 199 which follow the criteria that they either begin with or end with 2. So all these numbers are ending with 2. Let us talk about the next part. So let us take this 10 here and erase the remaining part. So what about the others? So we have the discussion now from 200 to 299. Obviously 300 is not included, neither ends nor begins with 2. But here in all these numbers you can see all the numbers from 200 to 299 are actually starting with a 2. So where is the doubt? All of them are following the criteria. So from 200 to 299, what is the number of terms? The number of terms can be written down as simply 299 minus 200 plus 1. Okay? So if you want to find the number of terms between 200 and 299, what we do? Take the larger number, subtract the smaller number and add 1. Why this one is added? Let me tell you the concept now. And this concept will be used further also. So let us take an example that what is the number of digits from 7 to 10. So the digits from 7 to 10 are 7, 8, 9 and 10. Overall there are 4 digits. But when we do 10 minus 7, 10 larger number minus the smaller number, 10 minus 7, what happens? That what is 10? If you take the number line basically, what is 10? 10 is at this position. And what is 7? Let me show it in blue color. 7 is at this position. So when you do 10 minus 7, you get this part. So in this part, as you can see, 7 is not involved. So we have to include 7 by just adding a plus 1. So the number of terms will be now 10 minus 7, that is 3, plus 1, that is equal to 4. That is the basic idea. When you have this kind of notation, that 7 to 10, what is the number of digits? When you do 10 minus 7, you exclude 7 from the discussion. So you have to add 1 in order to include it. Okay. Similarly, we have in our question, we have total number of digits will be 299 minus 200, right? But since 200 will be unincluded, we have to write plus 1 for that part also, and overall the number of digits will be 99. This subtraction is 99 plus 1, that is 100. So from this part we are getting 100 such digits. Overall we have 110 such digits which are following the criteria. So we have option number A as the correct option in this case. Okay, so this one more question is done. Here also there is no particular approach. You have to just apply your brain. You have to just play with numbers and think, right? Moving on to question number 12. So we have this particular product given to us. It says how many zeros are there at the end of the following product. Okay, so what are the two ways of finding a zero? I just told you few questions ago. You can have 0 by two methods, that is by simply a factor of 10 or by multiplication of 2 and 5, right? So here you can see there are various factors of 10. I am highlighting them. So here you have a 0, here also you have a 0, 0, here also and here also. All these numbers, there are 6 such numbers which are having 0 at the end because all of them are having a factor of 10, right? So I can simply rewrite these numbers as 1 into 10, this will be 2 into 10, this will be 3 into 10, this will be 4 into 10, this will be 5 into 10, and this will be 6 into 10, right? Now if we take all these factors of 10, 1, 2, 3, 4, 5, 6, we will have 6 zeros at the end. So out of this, we are getting how much zeros? We are getting 6 zeros. Okay, 6 zeros is written there. What about the other way of getting 2 into 5? So here you can see, you have a factor of 2 here. So you have eliminated 10 because you are already counting about it. So here we have 2. Here we have 4, which is nothing but 2 into 2. And here we have 6, which is having the factor of 2 into 3. Let us take 2 only. So we have 4 2's here. And accordingly, you can find a lot of 5's as well. So here is a factor of 5. Here is a factor of 5. 25 has 2 factors of 5. So all of them will find some factor of 5, right? And then we can get a 0 here also, here also, here also, and here also. So overall, 4 more zeros are possible by multiplication of the factors of 2 and 5. So ultimately, the number of zeros we get are 6 plus 4, that is equal to 10. So option number A is the correct option in this particular case. Okay. So now we have the last question of the day. Here we'll be talking about this recurring decimal. So as you can see, in this particular decimal we have 1.272727, and this 27 is repeating infinite times. So this is a recurring decimal, as I told you. The question says that the recurring decimal represented here is equivalent to what? We have to find the value of this particular number. So what can we do? Let me just show you guys. So we can assume this particular number to be equal to x. This number will be like this. X is equal to 1.27272727. Now what we can do, just look at the trick I am following. I am multiplying this number with 100. The number becomes 100x. And if we multiply this part by 100, 27 will come out. So we get 127.272727 till infinity, right? What we do with the same number, let us write x again. We get 1.272727 and so on. So since there are 272727 infinite times, it doesn't matter if I just pick out 127 for one time. The basic idea is, if there is an ocean and if you take a spoonful of water, it does not have any effect on the overall amount of water. That is the basic idea here. If we take even 127 out, the whole part will remain the same. So here, if you just actually subtract the numbers, this decimal part and this decimal part will cancel each other out. And so here you will get 100 minus x, that is 99x, and that will be equal to 127 minus 1, that is 126, right? If you find the value of x, it will be nothing but 126 by 99. If you cancel them out by a factor of 9, this value will go 14 times, this will go 11 times, and the value of the decimal will come out to be 14 by 11, which is nothing but option number B. So in this question, what we did, we just multiplied it by 100 so that this 27 part can come out and we can just cancel out the remaining decimal part. Okay, that is the basic idea of this particular question. So guys, this was the last question of this part 1, and thank you so much for being a part of this discussion, and I hope this discussion of number system is very helpful so that you can clear the 33% barrier of CSAT. Thank you very much.